We're going to be looking at practical applications of the laws of sine and cosine. Let's go ahead and take a look at example 1. As we read this, I'm going to underline some keywords, and the biggest part of this question is understanding what it's asking and drawing a picture. So that's what we're going to do. So a tree grows at a tilted angle of 4 degrees from a standard vertical position. So, right off the bat, you can kind of imagine a tree normally grows like this, all right? This tree is going to be tilted slightly at a 4-degree angle from that vertical. Keep that in mind as we continue reading along. There's a point on the ground that is 40 meters from the base of the tree, okay? So here's the base of the tree. There's a point somewhere that's 40 meters from that. Let's keep reading. So the second point's over here. And it says that it measures the angle of elevation to the top of the tree to be 30. So basically somebody has a viewfinder or something, and they look back over at that's not the top, whoops. They look back over at the top of the tree, which is tilted, and they read this angle to be 30 degrees. Okay? Final question, what is the height of the tree? We want to figure out, the tree's tilted, right? So we want to figure out how tall it is, even though it's tilted. So we can see we have a little triangle here. Now, I've already gone out of my way and drawn this picture full-blown, so let's go ahead and take a look at what we've drawn. What I just drew was a mini representation. Here's the bigger example. So somebody views this at an angle of 30 degrees. Okay, so this is 30. Now here's the tree tilted. It's tilted at a 40-degree angle, 4-degree angle from the vertical. So there's a couple things we can add in here as we draw the picture. I mean, the vertical, from the ground would be 90, right? So if the tree is tilted 4 degrees, then that would make a 94-degree angle right here. Okay. So next then we know this smaller side, not the smaller side, sorry. Well, it is smaller than the hypotenuse, but we know this side, and actually this isn't the hypotenuse because this is 94. But anyway, second smallest side, the ground level here would be 40 meters from the base of the tree to the, where the person is viewing this at a 30-degree angle. So we are given what after we draw this picture? Well, we are given this angle here, 94 degrees. We are given this, which is 40 meters. And we are given this, 30 degrees. Now, we don't know what this is yet. Looks like previously we'd solved at speed 9. I'm just going to go ahead and delete that for now, though. Okay. What we're really trying to solve for, though, is the height of this tree. Okay. Now, the question is, can we do it? Well, we have an angle, 94. We have a side, 40. And we have another angle, 30. We have angle, side, angle. And we know that we can solve angle, side, angle using either law of sines or law of cosines. Since it's angle, side, angle, we can actually use law of sines. Now, the only thing we need, though, is we need the angle opposite this side. The angle opposite side is going to be up here, formed between the top of the tree and the tree itself. Okay, and so we need to find this angle, but we can do that using the rule of 180. So once you know this angle and this side, then you can figure out this side using the law of sines, knowing this angle. So what do we know? We know big A is 94, little b is 40, big C is 30. For law of sines, it doesn't matter what you label what, as long as you're consistent. So next we will be solving for big B, that third angle. Step 3, determine which law to use. I'm going to use the law of sines for angle, side, angle. Side, angle, side, I believe you have to use law of cosines, which we'll look at later. Solve using the law, so either law of sines or law of cosines, depending on what we've learned. So A plus B plus C equals 180. We'll add these two up, subtract them from 180, and we get B equals 56. So this angle right here is 56 degrees, and since that's big B and we know little b, we can now use the law of sines. Little b over sine of b equals little c over sine of big C. Here's little c, and that's the height of the tree. We already know big C, so we're halfway there. So it'll be 40 over sine of 56 equals c over sine of 30. Cross multiply, and you get c sine of 56 equals 20. Now, here's the thing. I used a little bit of unit circle knowledge. Sine of 30 is 1/2, right? It'll just make our computation easier. You could use your calculator. It's going to say 0.5. But anyway, when you cross multiply, 40 times 1/2 is 20. 20 equals c sine of 56. Last step is to divide by sine of 56. So you'll get c equals 20 over sine of 56. And you get 24.124. Okay? 24.124. And that's going to be in meters because our original units were in meters. Okay. Now we want to convert 24.124, something that makes a little bit more sense. So notice this is a certain percentage of a meter. Well, there are 100 centimeters in a meter, so we can multiply that by 100, and that would give us 12.4 centimeters. So final answer, the tree is 24 meters, 12.4 centimeters high, and that's our last step, is to answer verbally. The height of the tree is 24 meters, 12 centimeters, and it's always helpful to go back to the picture and take a look. This is how tall the tree is that we just found. It is around a little over 24 meters tall. It's a pretty tall tree. It'd take a while to climb. Anyway, that's it for this example of a tree leaning and growing to a certain height. If you have any other questions about this, let me know.